So let's talk about one sample T confidence intervals and how we're going to calculate those. So the one sample T confidence interval for a population mean is similar in both reasoning and in computational detail to that of a one sample Z interval for a population proportion. So what we're going to do is we're going to draw a simple random sample of size n from a large population with an unknown mean, and this confidence interval is going to help us estimate this mean. So a level C confidence interval for mu is going to be x bar plus or minus, instead of z, this time it's t star for times the standard deviation of the sample over our sample size. And t star is the critical value for the t, which is the n minus 1 density curve, and the area C is between negative t star and t star. So like I've got this almost normal distribution, not quite with our mean, and we're going to calculate our confidence interval. So I've got negative t star, right? This would be our confidence interval. And the t changes depending upon our sample size. So this interval is exact when the population distribution is normal and is approximately correct for large n. So let's work through an example. So, does the expectation of good weather lead to more generous behavior? Psychiatrists studied the size of the tip in a restaurant when a message indicating that the next day's weather would be good was written on the bill. Here are the tips from 20 patrons measured in percents of the total bill. What we want to do is we want to estimate the mean tip for comparison with tips under the other weather conditions, right? We're just kind of building up to that. Like, so this said it was good weather, we'll probably do something with bad weather, but now we need to estimate the mean tip. So we will estimate the mean percent tip for all patrons in this restaurant when they receive a message on their bill indicating that the next day's weather will be good by giving a 95% confidence interval. So I have 20 patrons. That means my degree of freedom is going to be 20 minus 1, which is 19. We'll need this information to look up our critical T. So we check whether the following conditions are met. First, it has to be a simple random sample, right? This study was actually a randomized comparative experiment. As a consequence, we're willing to regard this as a simple random sample. Next, we also can't look at the population. We can examine the sample. The stem plot here does not suggest any strong departures from normality, right? It's all kind of concentrated towards 22 point some odd percent, right? So like here we've got a decimal point. So we can proceed to calculate, and I add up all my tip percentages and divide it by our sample size of 20 to get a mean. And then I also calculate our standard deviation. So we've got a mean of 22.21 and a standard deviation of 1.963. The degrees of freedom are n minus 1, which equals 19. So then we go to table C, and we find that for our 95% confidence interval, my T critical is 2.093. So the confidence interval is going to be our sample mean plus or minus our T critical times our standard deviation over the square root of n. So that means I got 22.21, our sample mean, plus or minus our T critical over our standard deviation over the square root of our sample size. This gives me 22.1 plus or minus 0.92. So that equals 21 to 21.29% to 23.13%. So we conclude we're 95% confident that the true population mean percent tip for all patrons of this restaurant when their bill contains a message about the next day's weather will be good is between 21.29% and 23.13%.